Hey, welcome back. This is episode 15 of the Salesforce Architect Playbook. Today, Salesforce Inbound API Architecture Masterclass, Composite, Apex REST and Bulk API 2.0. CTA Blueprint for High-Throughput Enterprise Integrations and API Limit Optimization. Let's get into it. Here's what we're covering today. Inbound Integration API Pattern Comparison, then, Standard REST versus Custom Apex REST Trade-offs, then, Composite, Batch and Graph API Optimization, then, Bulk API 2.0 Ingestion Architecture, then, API Governor Limits and Middleware Governance. Stay for the last one, it's the piece most tutorials miss. Let me explain this simply. Choosing the correct inbound API pattern is one of the most heavily scrutinized topics in the Salesforce CTA review board. If you choose synchronous Apex REST for high-volume data ingestion, your architecture will fail under governor limits and concurrent thread caps. As architects, we must align payload structures, latency requirements, and system limits.
So how do we establish clear decision criteria between Composite APIs, Bulk API 2.0, and standard REST endpoints when designing for enterprise scale?
Designing high-performance inbound integrations in Salesforce requires evaluating throughput, latency, payload structure, and transaction boundaries. Standard REST APIs provide instant out-of-the-box CRUD capabilities, whereas Apex REST endpoints offer custom processing logic at the cost of Apex governor limits. For complex transactional payloads, Composite APIs reduce network round trips by processing sub-requests in a single HTTP call. Meanwhile, Bulk API 2.0 handles massive asynchronous data sets efficiently. Selecting the wrong API pattern creates severe API limit exhaustion and system latency issues. Architects often default to custom Apex REST services without evaluating standard Salesforce REST APIs first. Standard REST API endpoints execute natively on the infrastructure layer, bypassing Apex execution time and governor limit consumption entirely. Custom Apex REST should strictly be reserved for complex orchestrations requiring atomic transactions, custom validations, or external ID upserts across deeply nested objects. However, custom endpoints introduce Apex CPU overhead and maintenance burden. Always benchmark standard endpoints before writing custom code. Composite APIs are a game-changer for reducing network latency and staying well within API request limits. The Composite Batch API allows up to 25 independent sub-requests to execute in a single call, while Composite Graph API executes complex dependent trees with transaction rollback control. Composite Tree API excels at creating hierarchical parent-child records in a single payload. Using composite endpoints eliminates chatty API traffic between middleware and Salesforce. This pattern maximizes throughput while respecting total daily API allocation limits. When payload sizes cross thousands or millions of records, synchronous APIs fail due to timeout limits and resource constraints. Bulk API 2.0 leverages asynchronous processing, automatically handling record batching, parallelism, and chunking behind the scenes. It simplifies integration design compared to Bulk API 1.0 by managing job states without manual batch creation. However, architects must account for asynchronous processing delays, row lock contention, and deferred error handling. Ensure your middleware implements robust asynchronous callback polling mechanisms. Placing an enterprise middleware layer like MuleSoft or any point platform between external callers and Salesforce is essential for enterprise security and resilience. Middleware abstracts complex payload transformations, enforces rate limiting, and implements circuit breaker patterns to protect Salesforce from traffic spikes. Furthermore, middleware handles token caching for OAuth authentication, avoiding unnecessary authentication overhead on Salesforce servers. Direct point-to-point integrations bypass these controls, creating single points of failure and operational risks. Always enforce middleware proxying for enterprise architectures. Managing Salesforce API limits demands a deep understanding of concurrent execution caps and total daily 24-hour API request allocations. Long-running synchronous API calls risk triggering concurrent API request limits, which cap long transactions at 20 concurrent requests lasting over 5 seconds. Exceeding daily request allocations blocks critical inbound enterprise integrations unless fallback queuing is implemented. Architects must implement streaming APIs or webhooks for event-driven polling alternatives. Proactive monitoring and rate limiting at the middleware tier prevent catastrophic outages. A common anti-pattern in high-volume integrations is sending chatty individual REST requests instead of bulkified payloads. Another critical error is omitting idempotent keys, which leads to duplicate record creation during network retry attempts. Heavy business logic embedded directly inside custom Apex REST classes often breaches Apex CPU time limits under load. Additionally, failing to handle row lock exceptions during high concurrency ingestion causes cascading job failures. Architects must enforce bulkification, idempotency headers, and asynchronous handling for heavy logic. Designing an optimal inbound API architecture requires aligning volume, response time SLAs, and transactional requirements against Salesforce limits. For low-latency single-record operations, standard REST API is ideal. For complex subtree insertions, use Composite Graph API. When ingesting over 100,000 records daily, transition immediately to Bulk API 2.0 to protect governor limits. Document these patterns in your CTA architectural decision records and establish automated performance testing. Continuous API governance ensures scalable enterprise integrations without unexpected platform throttling. Alright, let's wrap up. Here are the key things to remember. Prefer standard REST or Composite APIs over custom Apex REST to conserve Apex CPU limits. Use Composite Graph API for transactional, multi-SObject hierarchical record creation. Leverage Bulk API 2.0 for asynchronous ingestion of payloads exceeding 100,000 records. Implement Enterprise Middleware, for example, MuleSoft, for OAuth token caching, rate limiting, and circuit breaking. If this helped, hit like, it really helps the channel. Next up, Episode 16, Salesforce Outbound Integration Architecture, Callouts, Webhooks and Event-Driven Patterns. See you tomorrow.